This program is brought to you by Stanford University. Please visit us at stanford.edu.
This presentation is delivered by the Stanford Center for Professional Development, providing graduate-level education to working professionals, online, on campus, and on-site. For more information, please visit study.stanford.edu.
So today we have a speaker who I'm really pleased because he sort of combines two trends when I say what's happening with HCI in the future. So one, actually this is a comment that I had going to the recent CHI conference, is that a huge amount of the interest has moved away from desktop, laptop devices with a big screen and a standard keyboard to mobile devices. That's where the new stuff is all happening. Not all, but tremendous amount of the new interest. And so I think the next generation, the next decade of HCI development is going to be exciting new things happening on devices we carry. The other is in discussions of design, there has been a kind of shift from designing the thing to designing the environment or the ecology. And the big example everybody always uses is the iPod. So the iPod is a very pretty piece of industrial design, but that's not the reason it's successful. It's one of the reasons. But when they did the iPod, Apple thought about iTunes, they thought about distribution mechanisms, they thought about how you sell music, they thought about the iTunes interface, and that the thing that made it successful was thinking about that whole spectrum. And I think that what we're going to hear about today is another great example of that same kind of design thinking, is thinking not of the device, but thinking of the users, the complex, the whole environment for the user, and how to make that work together. And I think that, again, is going to be one of the things we see more and more of as people are dealing with more integrated products, more things that fit into their lives. So I'm very pleased to have Joe Britt from Danger. It's another thing, having somebody with a company named Danger, right? Who will talk about the development and the thinking that went into the Hiptop.
Hi, I'm Joe Britt. Terry, thank you for inviting me, and thank you all for coming to see me talk today. I'm going to talk about the development of the Danger Hiptop, which is known to most people as the T-Mobile Sidekick. It all started in 1999. Three of us founded Danger. Three friends who had worked together at companies like Apple, WebTV, and General Magic. All three of us had strong consumer product development backgrounds. If you look at the companies that we had worked for, it shows companies that you're probably familiar with. My background is in computer engineering, and my passion is using, designing, and studying consumer products. We'd all known and worked with each other for several years, and worked on a variety of different kinds of products. Let's see. This shows you the evolution of Danger's products. You can see from the first one that shipped towards the end of 2002. And what we didn't realize at the time that we were working at places like Apple and General Magic and WebTV was that the kinds of things that we were learning there about the tight integration of software and hardware and the power that could be availed by using a back-end service to enable a relatively weak device was setting us up with a lot of the kinds of things that we needed to know to build what would become the Sidekick. So today I'm going to describe how we framed the problems that we needed to solve to build the Hiptop, and which is a relatively complex product, and how we made the resulting various hardware and software design decisions. So given that the Hiptop is a consumer device and that consumers are notoriously difficult to design for, and the Hiptop is a successful device, according to this Gartner research, Danger devices represented 6.2% of global PDA shipments in 2006. I hope that you'll find the path that we took interesting and relevant to other aspects of human-computer interaction. So I've broken the talk into three pieces. First, I'll talk about the motivation for the product, and then I'll talk about how we put together the team that built it, and then finally, I'll talk. Most of the talk will be about how we actually built it and some of the design decisions and trade-offs that we had to make. So I'd like to frame the context for it first. I guess 2000 doesn't really seem that long ago, but when I started putting the talk together, I was surprised by how much fundamental stuff has just changed in a few years. All three of the founders of Danger were really into gadgets, and we were interested in making one of our own from scratch. We had been at several interesting companies developing other products, and we've been part of startups, but we hadn't ever done it from the beginning. In the beginning of 2000, when we started the company, the internet bubble hadn't burst yet, and there were all kinds of interesting companies going on in the valley. Most of them, though, were doing sort of strict internet-style applications, either for PCs or for some internet infrastructure. It felt like everybody was building some kind of portal, either specialized like Win.com or general purpose like Excite@Home. And venture investors were drawn to optical switching companies because it seemed like there was no end to the thirst for network infrastructure. So most of the mainstream development that was going on really applied to computers. And we wanted to build something that would be useful in this context of the Internet's popularity, but also would integrate the experiences that we had gained at other companies. And so we gravitated towards an idea that seemed most natural given our backgrounds, a small portable device that would allow Internet access. The closest analogs to this kind of product at that time were devices from Palm and devices from Research in Motion like the BlackBerry. Whenever we described what we had in mind to most people, we were immediately compared to those devices. And that concerned us somewhat because what we had in mind was similar in appearance to those devices, but the intent of it was very different. And anyway, while that was concerning, the thing that we were most concerned we might be emulating was this device, the General Magic device, which some of you remember, and I see some smiles in the audience when I put that up there. 6 years earlier, Andy Rubin, one of my co-founders, he had shipped this device at General Magic, and it had not become the great success that everybody expected. I had known Andy for a long time, all during the development of this product. My co-founder Matt had known him as well. We knew that there were a lot of very smart people at Magic and that there was a lot of very interesting and great technology in this product. So we were really worried that maybe we were going to repeat that part of history. I mean, we were asking ourselves, did the world really need another PDA? Would we be able to do something that was different enough from what the RIM and BlackBerry devices, the RIM and Palm devices could evolve into? So we thought about this for a while, and we came to the conclusion fairly quickly that timing is everything. When the Magic device came out, it was 1994. And so if we think back to 1994, I've put a couple of movie posters up here to help you remember, what was going on then. At that time, it's hard to imagine now, but there was very little consumer familiarity with email. The World Wide Web was still in its infancy. Programs like Archie and FTP were how people were finding and accessing things on the internet. And Magic had built a very sophisticated portable email and information sharing device, but just far too early. The original Magic device also lacked a radio. You had to cable it to a phone line to actually exchange information. Motorola wound up coming out with a version that had a radio in it, but because of the technology available at the time, it was relatively slow. And again, it was still in this time frame. It was before the internet had become really, really mainstream. So let's fast forward to the year 2000. Again, these are the movies that were playing in the theater then. The internet bubble hadn't burst yet, although we started the company. We incorporated the company in December of 1999. We really got started in February. And then around April, this popped, and it suddenly became very, very hard to start companies. So we started the company at a difficult time, but it also turned out to have some good aspects because there were a lot of interesting people available. But the most important thing was that now there was a context. Ordinary people understood what the internet was. They were having multiple IM conversations on their computers. They were using things like Yahoo and Alta Vista to search for stuff. They were using email to share pictures with their parents, who also had come to learn what the internet was about. The internet was everywhere. And so people were kind of ready for this. The analogy that I used to use was that when cell phones came out, it was very easy to understand what the context was, what the value proposition was. It was the same thing you were used to with desk phones. And the good thing about desk phones was the content, where the content is other people that have desk phones. So could we create something that would be so analogous to the experience that you get on a desktop computer from an internet point of view that people would immediately recognize it as being a high-fidelity reproduction of that experience? With that in mind, we started to look at what the devices were that were available in 2000. And this is the landscape. We have the Palm 7, which had an integrated radio, the Palm 5 with the OmniSky modem. which was an auxiliary product. That was a CD-PD radio that slid on the back. We had the first generation iPac. There was a sled that you could attach to the back of it and put a Wi-Fi card in. And there was the REM BlackBerry. We looked at all of these devices, and we used this to put together, let me make sure, yeah, we used this to put together a set of hardware goals for what we thought would be important. Consumer-friendly price. If we look back at the prices on all of these, they're all relatively expensive. The BlackBerry actually has the best entry price, but the monthly is very high. Is that okay? The Palm 5 and the iPac, those are all very expensive devices. So we put together a set of hardware goals for what we thought our product should have. It had to have a consumer-friendly price. We knew from our experience at working at other consumer electronics companies and from being consumers ourselves that the maximum would be around $300, and there had to be a path to $199.99. So we had to develop an architecture that would be able to scale down. Because it would have a wide area radio connection, it also had to have a consumer-friendly price point there. So we would have to work with whoever the cellular carrier was to provide that pricing as well. It had to have a screen that was appropriate for the content. So web and email content at that time with attachments was very demanding in terms of graphics. And it needed to have a QWERTY keyboard. If we look back, 3 of these devices lacked a QWERTY keyboard, but for doing email and IM, we felt like that was mandatory. Internet connectivity should be always on. Again, several of these devices, the Palm devices, required the user to manually say, I want to use the internet now. Switch over to internet mode, then switch back. 2 of these devices were what we called Franken devices, because you had this sled that you had to attach. Each part had its own battery. They had separate chargers. They would discharge at different rates. So it was very hard for the consumer to understand. It would be very hard for a consumer to understand what the battery life should be, or why things were discharging at different rates. Beyond these fundamental problems, though, these devices were also all very techy. You either had to be a techie person or you had to have some tech staff to support you. If you were a BlackBerry user, not such a big deal because you had some IT department that was helping you out, but ordinary consumers wouldn't have that. Okay, so given those hardware issues, we came up with these goals, and then we decided to take a look at the software aspects of the existing products, because we thought, well, while there are these hardware problems, those are pretty easy to overcome. And if the software that exists on the currently existing devices is close enough to what we have in mind, then maybe they'd be able to morph into the kind of thing that we have in mind. So we used all of these devices. The BlackBerry provided a very good email experience. It was state of the art, still is state of the art for corporate email, but it was very focused on text-based email. The screen resolution was very, very low. It had non-square pixels. We could imagine them fixing that, but in looking at the way the software was put together on that device, we felt like it would be a fairly serious overhaul to evolve past just text email. So next we looked at the Palm devices. They provided some rudimentary browsing, but they generally required specially created content. The Palm 7, for example, used Palm's web clipping service to adapt web pages for it. AvantGo was a popular third-party application. They didn't have a keyboard. We could imagine them getting past that, but their operating system was inherently single-tasking. All their code was native 68K code. All their applications from third parties were also 68K code, so they were locked into that architecture. So we felt like there were some hardware and operating system aspects of those products that would be very difficult for them to evolve beyond. And finally, we took a look at the iPac. The iPac provided the highest quality, the highest fidelity internet experience. It had a real multitasking operating system. It could run Linux. It could run Windows CE. Its biggest problem was the UI. The UI that was present on it was designed to be driven with a stylus. Parts of it were modeled after desktop UIs. And we could imagine grafting a keyboard on, but because of the extent to which the UIs were designed around that stylus, we felt like it would be fairly cumbersome for users to switch back and forth between the keyboard and the stylus. So we thought they would need a serious UI overhaul to improve the usability. So we felt like all the existing options had a significant software gap as well as hardware gap between where they were and where we wanted to be. Given those gaps and the belief that consumers were ready to understand and value a mobile device, we thought, great, this looks like something we can make a difference with. So we convinced ourselves that there really was a hole in the world, an opportunity to fill for this kind of product. And beyond that, it also seemed like something we would want to use, because we were all, of course, big users of the internet, and being able to carry it with us anywhere we went had a lot of appeal. So the first thing we did was we started building the team. With the conviction that we had around the product, actually even before we had fully convinced ourselves this was a good idea, we'd started speculatively building out the team because we knew that elements of the product would be common no matter what the final form of it was. So we built the team very slowly, opportunistically, with these 5 areas as the core domains of expertise that we would need to build this kind of thing. If we look at the hardware team first, initially it was just Matt, one of my co-founders, because he had the strongest background in hardware. But we shortly found a guy that several of us had worked before who was a very eclectic engineer who was really into solving the fairly wide variety of hardware challenges that were associated with this kind of device. It had to be small, it had to be low power, it had to have a large screen, which was contradictory with it being small, it had to have a big keyboard, which is also contradictory with it being small. Needed to have a cellular radio, which was fairly unusual stuff, at least to us and to this guy at the time, so that represented a unique challenge. And it had to be very, very low cost. Another aspect was the operating system, and VM here stands for virtual machine. We wanted to make sure that we didn't tie ourselves to a particular processor architecture, so we felt it was important that all of our applications be interpreted. It had to be small, it had to be fast, it had to be multitasking, it had to be reliable. We started looking at off-the-shelf options, but for anything that we would take off the shelf, it would have to be a very tiny OS, and we would have to adapt it to the hardware platform that we were building. And given that we had operating system experience and we knew of several really good low-level operating system engineers that were coming off of B that we had attracted to Danger, we decided to write our own. And that was also very attractive to those engineers, the idea of building a tiny new OS from scratch. So basically, we could have bought something off the shelf, but it would have been basically the same amount of time and effort as crafting this thing ourselves. So we chose to go that path.
Just completely running.
I'll get to that. So on the application side, timing was good for this part of the project as well. Several application engineers we knew from WebTV were looking for the next thing to work on, and the product that we had in mind shared a lot of the same sort of challenges that they had to overcome there, as well as some new ones, specifically around the network side of things and the screen size. But the product was something that was very appealing to them personally as well, and so it was relatively easy to attract very, very talented engineers to work on that part. The service, which is the back end that's actually connecting the device to the internet and adapting internet content on its behalf, the value of that was taught to us at places like Catapult, which was a network video game company that Matt and I had worked at, and WebTV, where Andy and I had worked. If you have a standalone device, then to provide an experience with similar fidelity to what you would get on a desktop computer, that device would also have to have a similar network connection, a similar amount of memory, a similar amount of processing power. So by having a bunch of machines at the back end that all of the little devices in the field could share, we could use those servers to adapt internet content and adapt internet protocols in a central location to forms that used less memory on the device, used less network bandwidth through compression, and abstracted the device from internet protocols that may be subject to change. Let's see. For the UI design, we knew that a small LCD screen would present some unique UI challenges, so we sought out a designer who had experience developing for the Nintendo Game Boy. Such a person would be used to solving these kinds of problems, designing for a small constrained display, designing visually appealing, fun, low-resolution graphics, low resolution being the operative word, designing for complex user interaction and a relatively small number of controls. And we were very fortunate to find a very experienced and available designer who had just finished a Sony PlayStation title and had some very impressive Game Boy graphic design work in his portfolio. So he was very eager to apply his skills to a non-game product, as well as influence the design of the actual hardware and the controls, because that's something that a game designer very rarely has. So I'll talk a little bit about the development philosophy. Experience at companies like Apple, WebTV, General Magic, as I said, had taught us the value of tight hardware and software integration. Often that level of integration comes from a design approach that features a lot of experimentation and iteration. Again, it also taught us the value of the back-end service. So those experiences formed the backdrop for the product development. And while each of the engineers owned their respective technical components, and the UI designer owned and drove the user visible hardware and software elements of the device, everybody worked together very closely. Everything was highly organic. Developing this kind of product, our belief was it required a very integrated team. And so the critical early design work was done as a continuous string of discussions and arguments and prototypes. And these were the 6 core elements that each of the teams had to bring together and fit, to turn out, to become the product that we had in mind. Prototyping was a key part of all of this early development. Mock-ups were created for the hardware. I can show some of those later. The device software, I have some screenshots of some early device software and UI, and service software. And then, as I said, we iterated to refine the designs. And the level of iteration varied depending on how far along in the product development we were. Okay, so now we've got the stage set to actually build a product. We have an idea, we have a belief that it's a good idea, we have a team that has what we believe are the right set of skills to put the thing together, and we have some concrete limitations as well to bound the design. So let's look at how everything worked to realize those goals. As I mentioned earlier, we knew that it had to be low cost. Battery life was important, the display was important, the keyboard was important. I talked about these a minute ago, but these were the key aspects of the hardware architecture. One thing that we didn't have a good handle on was what the radio would be. At the time that we were doing this, the analog cellular network was still in widespread use. The digital networks, the packet-based networks like GPRS and 1XRTT, those hadn't been deployed yet. We didn't know which one of those was going to become the mainstream one first. So we designed the radio as a module so that we could build the rest of the system around that, making it agnostic to what the particular radio was. And we used the non-radio aspects to sort of guide us along with the hardware goals, to guide us to decisions about what the CPU should be, what the memory should be, and what the display should be. So just for comparison, the Palm 5 had a 33 megahertz 68,000, 2 megs of RAM, modest 160 by 160 monochrome display. For power and cost, we decided to stick with a monochrome display. A color display would, of course, been a lot nicer, but it would have been around $40. The monochrome display was around $12, and it also used a lot less power to use a monochrome display. We found an off-the-shelf display from Hyundai that was 160 by 100 pixels, and it was 2.8 inches diagonally. It was roughly exactly the size that we wanted. It was fairly inexpensive, so we picked that, and that was our stake in the ground. We actually went through 3 generations of prototype with that display before we realized that it wasn't enough pixels and we would have to change it. So as an example of some of the design work that we did, these are early prototypes at 160 by 100 pixels of the topmost application we call the chooser, which is like a launcher that you use to get to all the other applications on the device. And you can see that there's this ring mechanism that's present in all of them. Early on in the development of the product, we found this control from Panasonic. It was like a wheel that would give you, if you can zoom down on that, it's like a wheel that gives you one-dimensional navigation, and then you can click to activate. It was relatively inexpensive and also very powerful feeling hardware UI element. And so we decided early on that we were going to build the UI around that. And so, that was what this ring was intending to convey to the user, that as they rotated the wheel, they would move around this thing, and then once they got to the application they wanted, they would click on it and drill into it. So we still need to flesh out the rest of the core hardware design so that we could make progress on the rest of the development. We had to pick a processor. We wound up picking the ARM7. The other contenders at the time were the 68K Dragon Ball, which was in the Palm devices. The issue we felt with it was that it didn't really have much of a roadmap. We had heard rumors that Palm was trying to evolve off of that onto an ARM processor because they didn't have a VM. They were having to convert all their applications like I was talking about earlier. Another popular choice was the SH series from Hitachi. Those were very common in cell phones in Japan. The problem was they weren't so common in the US. So ARM7 looked like the way to go. It was very popular. It was used in a lot of phones. It was supported by a lot of different vendors. So we ordered a dev board from Atmel off the shelf and used it to start developing our operating system in VM. This is a high-level overview of how that works. So here's the dev board. And then we took the Hyundai LCD and we built a PC board to mount it on and connected it to the dev board. And then we had a ROM emulator that we used to download code we had built on a Linux box to it. The dev board also, we built a board to let us hook up various keyboard prototypes that we used when we were designing what the keyboard would work like and when we were doing usability testing for different keyboard designs. This actually is it. This is the very first board that we ever used for development. This board has the little wheel on it that you can see. This connector would connect to one of 6 of these different keyboards that we built and ran through different usability testing to get the design of that dialed in. And that's what we used for the initial bring up of everything. We used GCC to build all the code. It wasn't as good as the real ARM tools, but it was free and it was good enough. We built a couple of these things so that the OS engineers and the VM engineer would have something to work on day to day. And because we had the LCD, we could also take UI design work that was in progress, put it on the screen, and see what it was going to look like. We basically just bootstrapped the thing as we needed it. We got some boot code going first. We had a C runtime, and then we would get the graphics code working as we needed it. So some of the font code came up first. Then we built a little preemptive round-robin scheduler, so we had threads, and then the whole thing just kind of came up, over time because everybody knew what the different pieces were that needed to be there. And so it was very easy to just talk about what the right way was to approach each of those problems. So back to the VM. We know that we wanted to have some kind of VM, but we weren't really sure if we were going to be able to make it work on a processor as wimpy as what we had. This board had a 33 megahertz ARM7. During the development of this, the hardware guys identified a part they liked better from Samsung because it was in a smaller physical package, so it would use less room in the device, had a better complement of peripherals, and best of all, it's cheaper. And it could run up to 50 megahertz, which sounded great. But the hardware guys asked us if it would be okay if we ran it at 24 megahertz because they were worried about the battery life. And at this time, we didn't have enough software running, so we were like, we don't know, but we'll try. So we'll set 24 as the goal, and we'll know we can crank it up to 50 later if we have to. So we're doing all this OS development, we're doing some hardware development, and there's one guy who's working on the VM, and it's his job to try to figure out, how can we make this work? We wanted to abstract ourselves from the CPU in case we wanted to change the processor in the future. We also knew that these low-cost CPUs didn't have MMUs, and we wanted to provide memory protection across the different applications that we're running. So would we have to create a custom VM? Initially, we thought we would have to create a custom VM. And that was our initial plan. And then we started thinking about all the other stuff that we were going to have to do, like build a compiler, build a debugger, build an integrated development environment. So then we started looking at other options. So Lua was one thing that the guy who was working on the VM was really into. So we looked at that very briefly. But all the applications guys, they had been prototyping apps in Java. They liked Java. There were great development tools for it. And a friend of mine, Paul Mercer, some of you may know him, he had a small company that was investigating Java VMs for small devices. And his office was right down the street from ours. We had dinner a lot because we were trying to figure this VM thing out as well. That was very popular dinner conversation. He had seen really promising performance with a number of off-the-shelf embedded VMs, albeit on slightly more powerful hardware than what we were contemplating. But because of that, and because of the tools advantage of Java and the familiarity by the apps team and the rate at which they were able to develop prototypes, we had to take a look at whether we could possibly squeeze it into the device. And so the VM engineer working on that had a series of revelations about how to make that work. Before he actually started writing the VM, he started doing a bunch of analysis of binaries for collections of Java programs to try to understand if there was anything that he could take advantage of. And in fact, there were two things that he could take advantage of. One was there was a lot of duplicated string data but across a collection of applications. And so one thing that you could do is you could remove all but one instance of a string and fix up all the references to that one and save a lot of memory. Another thing that he realized was that the Java compilers that we were looking at tended to emit long common sequences of instructions. And so it would also be possible to collapse those into single magic danger byte codes to reduce the number of Java instructions we would actually have to execute to run the program. And then the critical part was when he realized that because the service was the sole conduit for getting stuff into the device, we could take advantage of the service to massage a collection of programs however we wanted with a post processor before they actually made it to the device. And so then he started writing the interpreter with the assumption like, this is going to be really helpful, this is how we're going to do this. And because it was such a critical part of the system software, he wrote it in lovingly crafted, actually thumb instruction assembly language to run on the ARM processor. And once he had it mostly working, he figured he could execute one Java bytecode in about 24 thumb instructions. And we used thumb instructions because our memory bus was 16 bits wide. He could work within the constraints of thumb. You have access to less registers in the processor when you're running in thumb mode, but that was okay for this application. Being able to pack one instruction into one machine word or one memory word was worth it. We also realized that we needed to have we wanted to make those thumb instructions execute as fast as possible. So we decided that we were going to execute everything from RAM, which was very unusual for most of the mobile devices at the time. The Palm devices and the REM devices, they ran their code from ROM, which was significantly slower. So by moving everything to SDRAM, well, it had to be SDRAM because we needed more. By moving it all to RAM, we could achieve roughly a million thumb instructions per megahertz. So that would mean that he could execute one of these Java instructions in roughly 24 thumb instructions on average. So the next thing was, would that be fast enough? And what I came up with was what I call the Apple II argument. You know, we were essentially a 1 megahertz Java machine. Was it really going to be fast enough to do the kinds of applications that we had in mind? And I remembered, you know, my first computer was an Apple II. It had it was actually a little bit slower than a 1 megahertz 6502. It was like 0.89 megahertz because of the cycle stealing for the video. But there were plenty of games that did, you know, 280 by 190 pixel graphics with lots of things moving around on the screen. And so it just felt like, okay, yeah, I mean, we're kind of in the right direction. And then the other thing we had to realize was that we weren't going to do everything in Java. The high-level, the applications and the high-level UI toolkit would be in Java, and then we would partition it with a bunch of native method calls so that all of the stuff that was really performance sensitive, like floating graphics to the screen, rendering fonts, playing audio, all that stuff would be done in native code. And so it felt like, you know, by partitioning it that way, we could make it work. So we had the service assistants to help us with getting the memory size down and helping with the performance of the executed code. And actually, the performance wound up being good enough once we had it working that we had no problem multitasking. So we had 11 programs that were all written in Java that are running on the thing for email, web browser, IM, all the PIM apps, the phone app, all this kind of stuff. So we were multitasking preemptively all these things. The user would see, you know, the frontmost one, but everything was running in the background. The guy who wrote the virtual machine also wrote a garbage collecting memory manager that the Java applications all use to make more efficient use of the memory. Oh, yes. So another great thing about having the service is that we could use it to back up all of the user's data automatically. Sorry, I'm going to shift gears now off of the virtual machine and talk more high level about some aspects of the product. You've got all your stuff on this device. You've got your pictures, your email, your notes, your calendar appointments. But what if you lost it, or what if you stole it? With the devices of that time, like the Palm, you would have to dock it with a dock, and you have to cable the dock to your computer and install some software on your computer, and then you could upload or download software, which was a big pain. A lot of people didn't do it. But we had an always-on network connection. So whenever you changed something on your device, we could just send it up to the service and back it up there. Because it was also all mirrored in the service, we could provide the user with a desktop interface, a web browser portal into the service. So from your desktop computer, you could connect and look at all the stuff that you had. So that was unique and very interesting. The other interesting aspect of the service was that it would smooth out the wireless connection. Cellular connectivity, of course, has issues. There are dead zones. You go into buildings or elevators or tunnels and you lose the connection. And sometimes it's not a big deal, but there's certain applications for which that would be a problem, like an instant messaging application like AIM. If you're connected directly from the device through the wireless network to AOL servers and you lose your connection, then everybody on your buddy list is going to see you drop off the network. And then when you regain your connection, they're all going to see you come back onto the network. With the service, we could introduce hysteresis. If we have a service sitting between the device and the internet, and the service sees you unexpectedly drop off the network, it can speculatively hold the connection open to AOL, assuming that you're going to come back on, and then also buffer up any messages that come in the meantime, so that when you come back online, anything that you would have lost, you get. Sorry?
It goes the other way too.
Well, the buffering happens on the device. Well, you see that you're disconnected. I mean, there is some visual indication that you've dropped off the network, and you can type stuff. You can type in messages, and they'll just be stored on the device. And then when you reconnect, they'll flush out. The other nice thing is that it decouples the service. It decouples the device from the different protocols. So like AOL has their own proprietary protocol for talking to their chat servers. If you have a service in the middle, he's able to adapt that into whatever protocol we want to speak to the device, and there's optimizations that we can make on the way to the device. Also, if they want to change that protocol, instead of having to update the software on all the devices, we can update it in one location, and then everybody enjoys it. Let's see. This philosophy, right, of using the service to adapt existing protocols and formats for the device, that was at the core of the whole thing. Rather than try to make the device be able to do everything, let the service do as much of the hard work as possible. So I want to talk a little bit about the applications that shipped on the original device and still are the core applications today. Since we were trying to create a mobile analog of the desktop experience, we had good direction for what the application mix should be. The web browser was the most complicated application, not surprisingly. We had some experience with doing that at WebTV. WebTV also had a back-end service and had set-top boxes that displayed web pages, but the partitioning of the problem was such that there was a full HTML renderer in the WebTV box. So the WebTV service would do things like adjust image sizes, and if there were problems that could be fixed before the HTML was sent to the device, that was done. But the device itself was actually laying out the HTML for the screen. So we had seen how complicated that could turn out to be, so we decided to move the HTML parsing back into the service, have the service render in a simpler format page that was laid out at the appropriate resolution already for the device, and then send that to the device for display. Email, likewise, not as complicated as the web browser. Actually, the back end of the service has a fairly standard email server that speaks POP and IMAP to machines outside of danger. And then there's a program inside of the service that can reach into a user's email store, pull out messages, and adapt them appropriately before they're sent to the device using the device protocol. And we talked a little bit about IM and how that's helped. I'll talk a little bit about some of the basic UI elements. So here you can see 3 generations of the chooser. The prototype, this is our 1.0, and this is what we're shipping today. When we started the project, from looking at other phones, we knew that there were things that users always wanted to see, things like the battery level or the signal strength indicator. But keeping those things on the screen meant that we'd have to sacrifice some precious screen real estate. And at 160 by 100, it was especially painful. And the desire for that kind of omnipresent information, coupled with a lot of the prototype work that had happened during, like I said, the first 3 generations of prototypes of the device, led us to decide that we absolutely had to grow the screen. So the hardware team looked for an alternative panel. They found one from Samsung that was 240 by 160, which is the resolution of the devices today, 8th VGA, and it didn't cost much more. And the application and design team, they had their workflows established well enough by this point that they were able to prototype the different things that we had done so far at 240 by 160 to see how that increased resolution would help us and if it would solve the problems that we were having, and it did. So the 240 by 160 display was nice, but it was still relatively low resolution. We were only going to be able to present the user with the UI for whatever the frontmost app was, although there's all this other stuff that's happening in the background. And because these other apps are running in the background, they're going to want to let the user know that things are happening. So if you get an email and you're not looking at the email app, or you get an IM and you're not looking at the IM app, how is a good way to notify the user? Well, we already had this title bar thing that was already on the screen all the time, and so that seemed like a good place to put the notification mechanism in. So the result was this thing called the notification balloon, and it's like a little micro dialogue that appears on top of some of the other status indicators that are always visible. It's a lot less jarring than something like a dialogue, because it's not going to be the thing that if you're focused on something in an application, you're really paying attention to. And it also provides enough information. This is actually a little marquee that scrolls by. So if it's an email message, you'll see who the message is from and a little bit of the subject. If it's an IM, you'll see who it's from and a little bit of the IM message. And then you can decide whether you want to interrupt whatever it is that you're doing and respond to it, or just ignore it until later. The UI is also tightly integrated with the physical controls on the device. From the earliest mock-ups, this was one of our goals. Because the device needed to be pocket-sized but also needed a QWERTY keyboard, we thought it would have 2 operating modes. One, a closed mode where there's a set of core controls that are always visible, and then a QWERTY keyboard that could be exposed. But we also felt like it was very important that the display always be visible. When we were doing this initial development work in 2000, caller ID was just becoming available on cell phones. A number of us had clamshell Motorola cell phones. Whenever we would get a call, we would have to pull it out and open it to see if we wanted to respond to whoever it was that was calling us. And we thought that, gosh, people are going to be getting so many more messages on this device. They'll be getting IMs all the time and emails all the time, and it's going to be really annoying if you have to open the thing up each time that happens to see why it's trying to get your attention. So we wanted the screen to always face out. And we had thought about different ideas like sliders. Now, there are phones now that have dual LCDs. They have one on the outside. But at the time we were doing this, at least in the US, that was extremely uncommon. And it would have also added cost to the device. We wanted to avoid that. So we were trying to figure out a way to make the screen always face out. And we, like I said, we had thought about making a slider device, but there were issues with the hinge and how much you could actually slide the thing up. And so we were trying to figure out how can we do this. That hardware engineer that we hired, the day before his first day at work, we told him about this problem. And the next day he came in, and there was actually a meeting going on his first day at work. And he came in and told everybody, I got it. I figured out how we're going to do it. And what he did, and everybody's like, what are you talking about? So what he did was he took a Post-it notepad and he drew a screen on the top of the Post-it notepad, and he held it out, and everybody's like, yeah, so what? Then he peeled the Post-it notepad apart from midway through, and he drew a keyboard. Everybody's like, okay. And then he stuck it back on, and they're like, no, that can't work. You're still going to have to do the slider thing. And then he peeled it again, rotated it 180 degrees, and stuck it back on. And then the whole room was just quiet. Everybody was just absolutely silent, dumbfounded. It's like, okay, that's brilliant. That's the way we're going to do it. That is absolutely the way we're going to do it. And so, all we have to do is there's a magnetic sensor that detects which orientation the screen's in. So the software paints the frame buffer in the appropriate way. So we had figured that out. But because the screen was always going to be facing out, we wanted to put a hard plastic cover over it, because you're going to have this in your pocket, and you don't want to be pressing up against the glass. If you had a touch screen, you just have like a thin sheet of Mylar over it, and you could break it really easily. So we felt like we should have these hard controls, and we thought about making soft controls, but we played around with that a little bit, and the UI looked like it was going to be possibly very confusing if the meaning of buttons changed in the middle of the user doing things. So we really wanted to come up with a core set of very, very simple buttons that you could use to pick up the device and quickly navigate through the core features. And so what we came up with were these four controls. There's the scroll wheel, which we talked about a little bit earlier, which lets the user do one-dimensional navigation and then take some action. There's the back button, which if you think of this as the action button, the back is like the unaction button. So you click to do something, to drill into an email message and display it. You hit the back button to back up one level. If a dialog box comes up, you hit the back button to get out of that one level. The jump button always takes you back to the chooser, the top level thing. So you can think of the UI as being organized as there's this top level chooser that has your collection of applications, and you drill into them with the action button, and you can drill into them in parallel. And then you use the back button within each application to navigate that stack, and then you can hit the jump button to always bring you back to a home location. So no matter where you are, if you get lost, you can hit the jump button, and you'll always come back to the top level. And then there's a menu button. Oops. Then there's a menu button which brings up a context-sensitive menu. So depending on what the application is or where you are within the application, that'll bring up the menu items that are appropriate for wherever it is that you are. And the controls, they felt very natural once we mocked them up. New users often remarked at how surprised they were. They could just pick the thing up and play with it for a few minutes and figure it out really, really quickly, how to use the most important features. Now, we also added a bunch of power user features. So, once you become more experienced, you can do things like map each of the applications onto one of the QWERTY keys on the QWERTY keyboard and then chord the jump key with one of those to jump directly to that, no matter where in the UI you are. So, you start out with something that's very easy to discover, and then once you've discovered to a certain level, you can discover more that lets you use the UI in even more powerful ways. This is the flip screen. I already told the story about the Post-it note. That was a very good idea, and it is the signature hardware feature of the device. For the QWERTY keyboard, we had to figure out all the details of the keyboard. We knew we wanted to have a keyboard, but there's all kinds of variables like key pitch, the number of keys, the layout, the geometry. We took a look at all the existing thumb keyboards on things like the BlackBerry and two-way pagers, and the conclusion we came to was that none of them were really suited for the massive amount of text input that we thought our users would want to do. For one thing, the existing keyboards were very cramped. The space between the keys was very small. So there is a trade-off, of course, between the size of the keyboard, the size of the screen, the size of the device, and there's a balance to strike there. But we felt like it was important to go a little bit bigger just so that we could have a roomier and more comfortable keyboard. The existing keyboards we looked at also lacked number row keys, and the designs for those instead chose to embed them in the other array of keys. But one of the other things we wanted, there were two aspects of that we didn't care for. One was we felt like for the kind of communication we thought our users would be doing, they'd really want to use numbers a lot to enter a date or a time or an address, and having to use some meta key to get at the numbers could be very, very cumbersome. We also wanted to provide more alphanumeric symbols than the existing keyboards did. We wanted to place them geometrically on the keyboard in roughly the same places they were on PC keyboards, so that people coming from a PC keyboard would be able to find them very easily. Even though there weren't existing keys for them, the general layout of them would be the same as on a PC keyboard. So the screen size actually helped us a lot in this regard. We'd set this 2.8-inch, we'd found these 2.8-inch screens that were roughly the size we wanted, and also because they were 240 by 160, they didn't have a standard 4:3 aspect ratio like a TV, which tends to make everything squat. And if you're using that to define part of the overall length of the device, then that's going to tend to compress the keyboard. By being 240 by 160, it's more like a 16 by 10 aspect ratio, so it tends to be wider and gives you more room for spacing in between the keys. We had a lot of arguments about, should we really include all of these non-alphanumeric symbols? Do our users really need squiggly brackets? Are they ever going to understand the difference between slash and backslash? We wound up putting pretty much all of them in because we felt like they would be needed for not only URLs and the applications that we were including, but future internet applications that we may not know about yet. So we wound up building 6 different prototype keyboards and trying to figure out the details of the spacing and size and layout. This is one of them that I'm showing here. This is it in real life if anybody wants to come check it out afterward. The other 5 are lost to the winds of time. I looked around and tried to find them, but I don't know what happened to them. This one is interesting. This one was called Smiley. And it doesn't have a dedicated row of number keys, so it was one of the ones that didn't make the key, and he's lost a couple of teeth over the years. So, with 6 keyboards and a small number of friends and family coming in to do usability testing, it was hardly exhaustive research, but we were a small company, and in hindsight, it was probably best since it let us make a decision very quickly, and we all liked it, and we felt like it struck a good balance between all of the variables. So I've described now several of the main components that make up the whole thing. Here's a block diagram showing you how we have the device out here that connects through the carrier's network into our service, and then our service provides multiple connections out to the internet and also provides a mechanism for end users to access their data from a desktop computer. It took us about a year and a half to get most of these pieces defined and built. So by 2001, we had functional devices that everybody at Danger was carrying around. It took us about another year to get all the radio stuff working reliably enough to ship. So during the time that we were beating on the radio and bringing it up to speed, we had time to refine and tune and fix bugs and everything else. Once we had everything working and we were able to start using it in the real world, we started discovering things about the device that made sense, but we hadn't ever really thought about. There's this surprises within surprises quote on here. This is something that I used to say because whenever we would show this to the people for the first time and we would flip it open, they'd be like, wow, I've never seen anything like that before. And they would respond very viscerally to it. And then as they picked it up and played around with these core controls, they would discover how to use it, and they would be pleasantly surprised. And then they would discover how to access the next level of functionality. They'd become surprised again. But what happened was we wound up being surprised. One experience that especially sticks out in my mind is Matt and I went to dinner at Ilford, with a couple of investor guys before the product shipped. And so Matt and I were the only two of the few people on the planet that had the devices. And we were having our own little secret conversation under the dinner table via IM while we're talking to these guys, above the table. And after dinner, I was like, wow, that was really cool. It's like we had telepathy. We were able to have our own private conversation these guys had no idea about. But then what Matt told me was like, oh yeah, and while I was talking to you, I was also talking to Kiva, who was at the factory in Thailand, and they're building devices. And that just totally blew my mind. The idea that not only do we have telepathy across the table, he's able to talk to somebody on the other side of the planet. So he's having conversations with 3 groups of people simultaneously, and he's the only one who knows about 2 of them. And let's see. Well, we have a few minutes. I'll tell. I have 2 other stories. I was going to tell if there was time. One was about Thailand. When we built the product initially, the current generation products are built by Sharp in Japan. Ever since Sidekick 2, Sharp has done the manufacturing for us. For the Sidekick 1, the black and white and the color device, we built them ourselves through a contract manufacturer, the first one in Thailand. And we had sent the assembly instructions and all the part lists and everything to the factory, and they translated the assembly instructions to Thai and sent them back to us to verify. And of course, none of us spoke Thai, right? So we're looking at this thing. So what should we do? Then Matt had a great idea. We should go have lunch at Siam Royale. So we walked down the street to on University Avenue to Siam Royale, and after lunch, Matt went up to one of the waitresses and asked, would you like to make some extra money, after work? And after explaining, exactly what he meant by that, she agreed and came down to our office at 124 University Avenue and sat at a lab bench and followed the assembly instructions and built a Hiptop, from the Thai instructions. So they were perfect. Another interesting story was that Matt and I were going to. It always seems like we're going to eat lunch, but I didn't realize that until just now. But we were going to La Morenita this time, and we were talking about construction because I was doing some work on my house, and we were talking about drywall. And Matt said, "How long has drywall been around?" And I was like, "I don't know." And then I realized, hey, I've got Google right here. So I looked it up, and it turned out it was like the 1880s. But that was an eye-opening experience for me because I realized that now no matter where I was, I had all this knowledge of the internet right here in my hand. So not only could I communicate with people telepathically, but I could also be, all-knowing, right? I could find stuff out really fast. And so, having used the product now in all of its incarnations for close to 6 years now, I have a hard time remembering what it was like without it. And whenever I can't use it for whatever reason, I have something that I think must be what separation anxiety feels like, because it's like a phantom limb. I keep reaching for it and it's not there. And I think a lot of our users feel the same way. So what I'm trying to get at is that, I mean, I'm a technologist, so maybe it doesn't apply to me, but as technologists and engineers, it wasn't easy to keep the design and operation of the device as simple as we have. But from the beginning, we realized that there are a lot more ordinary people on the planet, people that work at the mall or a restaurant or go to school, who aren't technologists or engineers, who use the internet for purely personal communications functions. So we try to keep that in mind throughout the development process, and purposely hid as much complexity as we could. I mean, we tried to do all the hard stuff so our users wouldn't have to. And my mom, who absolutely would not describe herself as a technologist, uses the product in exactly that way. She has a Mac, she does email with it, but with the Hiptop, she can send and receive email to me all the time. She takes pictures of her dogs and mails them to me. I mean, it's that kind of stuff, right, that makes her really happy. It's a simple product, and it does what she expects it to do. Let's see if I can go to the next slide. Hello. Thank you. That's it. Yes.
So I have one initial question. Which
Sure.
is, when you showed the comparatives and we're talking about those things, they're all American.
Yeah.
And of course, Japan and Korea, places like that, have been way ahead of us in mobile functionality. Did you look at all the various things being done there and compare and get ideas?
Well, we wanted to. I mean, practical considerations intervened. We looked at those things as much as we could, but we were also trying to take advantage of what the mainstream uses of the internet were in this country, because we knew we were going to ship here first. And we personally, since we were doing all the development, we felt like we understood that in a way that we wouldn't really be able to understand without also being parts of those experiences. And we didn't really feel like there would be total overlap. So we had to pick something, right? So we picked what we knew best, the US. Since then, we have looked at, especially at Japan, right, because our device manufacturer, Sharp, is in Japan. My wife is Japanese, and we got through her father an iMode phone, and so I was able to use that when I was in Japan. And some parts of it are very advanced, and some parts of it, admittedly, this was a few years ago when I was looking at it, some parts of it were surprisingly limited, right? Like, they decided that they were going to build a parallel internet, which was CHTML content, and Docomo had enough might to actually do that in a way that WAP wasn't done on the rest of the planet. So as long as you're going to CHTML sites, as long as you're looking at content that was designed for those phones, it's fabulous. But when you try to go outside of that, then weird things start to happen, like images don't show up, or it truncates at 4 kilobytes. So in that regard, I think that we've done the appropriate thing for the users in the US who were already accustomed to the desktop experience, whereas people in other countries didn't necessarily have that experience as a starting point, when they were looking at something and what their expectations should be. Does that make sense?
So I was curious it's amazing how many things are still in the UI today from 7 years ago. It's like, man, you guys figured out a lot of stuff right.
We didn't have cut copy and paste.
Was that?
We didn't have cut copy and paste in the first version. Now we do. We've had that for a while now.
But I was curious, what was the main thing that shifted, or that you feel like you got wrong in the first version? Oh yeah, we thought it was going to work like this, but as soon as we realized we realized it's not like that.
Cut copy and paste.
Yeah, I mean, we knew cut copy and paste was missing. There were pieces that we knew that we wanted to add that we just cut copy and paste was one of those things. I mean, even though it took us a year from when it was working to when we could ship it because of the radio, we didn't know it was going to take us a year to ship it because of the radio. We didn't know how long it was going to take to get the radio working right. So once we got everything basically working, we didn't want to change a whole lot of stuff. We wanted to just kind of tweak it because, of course, within 2 weeks we were going to be able to ship this thing because the radio was going to be fine.
And we should clarify, you and I talked about this at lunch, but that you were saying that you had the whole device ready, except for the radio, and you basically got this thing ready to go out the door sans radio.
Right. So we were using it for about a year without the radio. But back to your point, things that were missing. Cut, copy, and paste. We intentionally left it out for perceived schedule reasons, although in hindsight we could have put it in. There were other things like that, right? Like now we have a hierarchical chooser. So that top level thing that you go to, now they're essentially folders. So you can have a folder for games, a folder for your PIM applications. In the original device, we didn't do that. In the original device, it was everything was just flat at the top level. So that was a big piece that we added. Other things like scalable fonts, right? And a lot of bitmap graphics. Oh, here's a good one. Let's see if I can go back and find it. That picture of the original UI. This background, these were called the chicklets. And this is almost like a silly thing, I don't know. But these chicklets, they didn't really exist all across the background of the screen. This graphic was created with them, and then each of these guys were just sort of composited on top. So anytime there's a graphic like this for each application. So there's one for the phone screen, one for the email client, one for the IM client, one for the web browser. And each one of those has their own splash screen graphic here. They had to have the chicklets embedded into them so that they would mate up with the chicklets that were behind the menu. So it was a total hack. So cleaning that kind of stuff up, that was something that we did relatively quickly, again, because we thought we didn't have as much time as we did. And it came back to bite us a little bit because by the time we fixed it, we had third-party applications that had done this treatment, right, for their splash screen. So then we had to go back to those guys and say, okay, can you please change the way this works? So there were things like that, but I don't think there were any really big major things. Yeah?
The bane of the third-party application people is having to support yet another platform.
Yeah.
How did you deal with that?
We embraced people who seemed very enamored of what we had done, and we used them to bootstrap it. And that worked very well for a small number of developers. And then we extended. So the other thing I should point out is for our Java implementation, we looked, when we were doing all this, we looked at what was available in terms of J2ME and MIDP, standard implementations, but came to the conclusion that the UI toolkits were just too primitive to do what we wanted. So we eschewed all of that, and we created our own UI framework. and actually it looks kind of like the B UI framework if you look at it, because a lot of the guys that worked on it came from there. But it's a very rich set of UI elements that you have to work with. So we embraced a small number of developers that were interested in building something for a new platform, and then over time we built out the J2ME infrastructure. So then we could open it up to a wider class of developers and say, hey, you've already got your J2ME applications. We can run it if you want to run it that way. It doesn't look so good next to all these other things. And so that way you can kind of encourage them to update their application to take advantage of some of the more advanced features. But that was basically what we did. We opened it up so that it was easier for existing developers on other phones to port their applications. Yes?
To dial the telephone number, you'll have to open the flip, then press the number lock, and then dial the number.
Well, if you have it locked, you have to press the number lock. The phone UI, actually if we put it up here, if you can zoom in on the screen, you could dial with the number pad. A lot of times, the most recently called numbers will be in your recent list. So, I don't know about you, but I call a relatively small number of people. And so normally they're just right there. So I don't have to open the device and enter their number manually or their name manually to look it up in the address book. We were very concerned about that. T-Mobile was very concerned about it as well. Another nice thing about having the service on the back end is that we can look in aggregate at the popularity of various applications. There's reporting that comes up about how things are being used. And the number of voice minutes that are used are far, far higher than we or T-Mobile expected them to be. So it appears that people are understanding this recent list concept, or they just aren't being dissuaded by the fact they have to open it and use this. Now you'll see here there is an embedded number keypad. That's a difference from the original device. The original device didn't have the embedded number keypad. The user just had to use this. One big problem that did exist with this was that if you had any kind of visual memory or muscle memory about using the keys on the dial pad, it totally broke here. So that was one of the reasons that we moved to this, so that you would recover that ability.
Phones are 1, 2, 3, 4, 5, 6, 7, 8, 9, where keypads tend to be.
Yeah, so actually, there's just not enough detail, I think, on the camera. If you zoom way in, so here, the top row is still 1 through 0. This one, there are multiple symbols per key. So you see the Y and a 1, the U and a 2, and actually Alt-U gives you underscore. And then also there's some contextual stuff that happens when you're in the phone app. Like it starts paying attention to what keys you're hitting and then tries to guess whether you're trying to use it in embedded dial pad mode or QWERTY keyboard mode.
Oh, yes. So you get some information back from your back-end stuff. Do you get enough to tell what sequences of commands are issued by users?
We don't do it down to the level of which individual buttons have you used. There's some stuff that we do that for. Like we were worried about the reliability of the hinge, so we upload how many times the hinge is open and closed. So we can look at that in aggregate, and then we can look at failures that come back from the field to try to understand, okay, people are just flipping this thing a lot. Or they're flipping it a lot and they're not coming back, so the hinge is probably fine. Normally it's stuff like, what are the most popular applications? What are the most popular websites? How many minutes are people spending on the phone? Higher level functions. But there's nothing to prevent that from actually looking at individual key presses for everything.
You could make more UI experimentation with it, but so far you're mostly living on statistical information.
That's right.
In the aggregate.
That's right. Yeah.
Could you elaborate a bit on?
Oh, sorry.
Yeah.
Yeah.
So it seems like small screens always going to be a problem with devices like this, right?
Yeah.
Have you thought about using a virtual desktop? You can like pan across?
Well, better, I think we've thought about making the screen high resolution. This display, it's 8th VGA. There's a lot of phones that are coming out now. If you look in Japan, that's sort of the gold standard for screens. There are wide VGA screens there now, which I think are like 800 by 4 something. That are 3-inch displays. So you can cram a lot of information. Now, admittedly, everything gets really small, right? You have to have really good eyesight unless you just blow the fonts up. Yeah. But is that sort of what you meant, or did you mean like using it in conjunction with a computer?
No, I mean just, yeah.
Using it in conjunction with a computer. Well, let me tell you about the way that I use IM, and then you can tell me if I'm still misunderstanding the question. So like with IM, it's the application that users use most, and it's the application that I use most. And I stay logged in from the device and from my desktop all the time. So if I'm sitting at my computer, I'm just using IM there. And then if I get called away to something, I have my device and I go with me, and like the same conversations are right there with me. My email is also the same way. Like my email comes to my desktop computer and it comes to my device. Now there's some things, right, like my web browsing history that's not common between the two, but is that sort of what you meant?
So I have a laptop, right, that only has a 1400 resolution.
Right.
And then I have a monitor that has 1900 resolution.
Right.
And if I take whatever is on, if I switch between the two,
right,
then my monitor desktop goes on my laptop and it gets just like this virtual desktop where I can pan across.
I see. So you want to reproduce like the desktop UI on the device.
Native to
right.
desktop resolution.
Right. Okay, so that goes back to some stuff that we had looked at WebTV a long time ago. Because we had to relay out the web pages to fit on it was essentially a VGA screen, 640 by 480. And we did usability, or WebTV did usability testing that showed that if you let the user pan if you let them pan around, you know, horizontally as well as vertically, it was pretty easy to get vertigo because there can be places on a web page where there's not much content, and if you find yourself scrolled over into one of those, it can be hard sometimes to find out how to drag yourself back out. So we made a conscious decision to compromise the pages somewhat by forcing them to only scroll in one direction. So it was a conscious decision, but sure, we could, I mean, if it made sense, we could do that. I think as the screen resolutions get higher, it'll become less of an issue. Specifically around VNC, there actually is a third-party application. I'm not sure if it's shipping. There's a third-party application that'll let you do very slow VNC from the device back to your desktop, like real VNC, so you can connect, you know, from your Hiptop. Yes?
Do you have any experience with updating what happens on the machine by changing what's in the back end? And what's your experience with users when things change in front of their faces?
Well, we try not to make the UI actually change in front of their face. In the UI, we keep constant, or we add new functionality. But in regard to how they respond to it, I'm just trying to think of an example. I mean, we've done things like improve the performance of the web proxies, so web browsing speeds up. So of course they like that, but that's not really a UI change. It's more like an experience change. Is there some example in particular? Yeah, normally we don't really change the UI to
I would think that would be problematical and people would not like it.
Yeah, if you do that, then you're just going to make them call the carrier on the phone, and they don't like to get phone calls. So we try to avoid doing things that will cause them to do that.
How much of what's on the phone is incrementally downloadable by you just sending all the software?
The software. Yeah, everything, even the radio software. So the radio's got its own processor, its own ROM, but we can update all that stuff over the years, and we've done many times to all our users. Yeah.
You commented that you use your own protocol between the device and the service that is generic and more stable, and then you have backends that do a variety of mappings.
Yes.
You commented that you could do an upgrade of one of the backend protocols without having to change.
Right.
Of course, that always requires that the generic protocol that you're using have the right set of services.
Sure. So the main example where we thought that would be an issue would be like the IM clients, where it's true they could add some new functionality, like if there was a way to do video IM, right? The client can't do it anyway, either because of the network connection or because of the processing power on the device. So you just don't get that feature. But if they do something, like it was the case, at least several years ago, when several people were trying to build third-party clients for AIM, and AOL didn't like that. And so they would periodically tweak the protocol to break those clients. We wanted to make sure that that wasn't a problem. That was one of the main drivers. I mean, that plus the fact that we didn't want the device to be directly connected to them for the reasons that I was talking about earlier, like if you lose the connection. But that's the sort of thing that we're able to deal with, right? I mean, we have a relationship with AOL, so they'll give us a heads up if something's going to change, and we can update things in the server in an appropriate way. Sorry.
After your experience with 3DO, how concerned were you about the adoption of the Hiptop, and if so, how did that affect your design process?
I don't think that affected I don't think that really affected it at all. At 3DO, it was a new form of an existing thing, a video game console, whereas what we were trying to do was provide a new way to access content that didn't exist yet, right? I mean, there weren't any phones that provided real internet access at the time. There were WAP handsets, or there were things like the Palm and the BlackBerry and the iPad. So I guess we just all felt like it was a very different beast, than what we were trying to do at 3DO.
So I imagine when users first started using one of these, they already had a list of contacts someplace, like a,
Right.
How did you handle getting that into the device so they don't have to put it in by hand?
Oh, frankly, fairly poorly for the initial device. We had an interface through the desktop interface, so people could import things through a browser. A little bit later, we allowed people to download IntelliSync. We worked with IntelliSync to let them synchronize. But again, they would synchronize, instead of like, the way IntelliSync would normally work is you would cable your Palm device to your computer, run this thing. With the IntelliSync client for the Hiptop, you'd run the client on your desktop, but it would connect over the internet back to the service, and it would sync everything with the service, and then the service would sync everything with the device. There was also a client from MarkSpace for the Mac to do the same thing.
Is there video potential for this?
There's potential, yes. It's not there yet, but there's definitely potential. Well, it depends on how you do. Well, it's certainly processing power, but the newer devices have a memory card slot, so you could do content that you're playing off of the memory card. For video, we've seen some experiments that indicate that even with edge data rates, you can get reasonable, albeit postage stamp sized video. But it is a carrier concern, right? How much of the network it'll use. Yeah.
User demographics.
18 to 34, mostly female. Well, Matt's here, he's going to correct me. It's very close. It's very close, male to female, but it sure does seem like whenever we see pictures in the media, it's women who are using the device. Yeah.
Because you own the channel that the device uses, it seems to me you have an opportunity to give seamless, i.e. continuous service as you transition between, say, the T-Mobile wide area versus Wi-Fi.
Yeah, the issue that you have, we do, and that's also something that we've been looking at. There's this thing called UMA, which is like the Unified Messaging Alliance. I've forgotten what it stands for, but it's basically that. It's doing handoffs between Wi-Fi and wide area networks for voice calls, but you could also do it for data. The biggest issue I think we would have with that is our data center is connected to T-Mobile or whoever the carrier is, either through a dedicated link or through VPN. And so if you're coming in through some random hotspot, then we've got to build some kind of channel for them to get into the service. And there's security issues with that, so you've got to figure out how to deal with that. So, yeah, possible, but
Compared with what you've done so far, that's actually an easy one to do.
Thanks. Yeah.
Location awareness to improve the user experience?
All the time. Yeah, we have. Actually, we have a very early patent in the company around doing location-based services for IM. We've been thinking about it from the very earliest days. It all comes down to just cost and size of the device, because putting the GPS receiver and the antenna in the device does both of those. It increases the cost and the size. But absolutely, that's something that we think is going to be very important. Cell location, it's interesting. We get the cell tower ID from the radio. And when we were in that phase in 2001 when we were doing a lot of danger-only testing of the thing, one of the guys wrote an application that would grab the cell tower ID and then upload it to the service and then ask the user, well, it would do things. It would upload it to the service, and then if the service didn't recognize it, it would tell his application, I don't know where that cell tower ID is. And then his app would pop a dialog up and say, where are you? And then you would type that in, and it would upload that to the service, right? So we built up a database of all the different cell towers, basically between here and San Francisco. But the problem is that when the carriers deploy new cell sites, they shuffle the cell tower IDs. So you really have to have access to their database to make good use of it.
Because they do this for 911 now.
Yes, yes, you'd think so. But, but that system is not designed for high volume. So the number of queries that you can make to it is very, very low.
But you have access to the I mean, when they build a cell tower, they have to fill a form at FCC, so you can get that information.
I don't think they have to disclose where cell tower ID X physically is.
They don't, right, they don't have to disclose the ID, but they have to disclose where the physical location.
Right, but we don't know how to map the ID onto a location.
Oh, I see. Okay. Self-implemented.
Yeah. Well, we have a relationship with them. It's just they, yeah. So I think GPS is the way to go for that, right?
Building coverage and GPS.
Well, with AGPS, you do, right? Because then that is taking advantage of the self-structure in a way that is sort of mainstream doing what we were just talking about.
Do these things make noise?
They can.
Do they ring?
Yes.
Have you given any thought to providing some way that a restaurant or a theater can do something that says, hey, don't ring here?
It's interesting that you should mention that. We haven't, but I've looked at, in other countries, like in Japan, it's legal to buy a cell phone jammer, and sometimes restaurants will put those in their building so that whenever you...
Really a sledgehammer
You can't do that in the U.S. Although I guess they do that in some casinos. I don't know how they're able to actually do that, but I've heard that in casinos in Vegas.
Everything's legal in Nevada.
Or you can just shield it. Just make your building
a Faraday cage,
RF.
right? So you go in, yeah, you could do that. Yeah, that would work. But as far as making it so it doesn't ring in a restaurant, no, we should think about that.
It would be nice to have a $30 politeness signal.
Right. So then it's a good idea. We have to convince, it would only presumably work with certain phones, right? The phone has to know how to pay attention to it. But yeah, that's a good idea.
Do that. Maybe you can do that through Bluetooth.
Yeah, sure. Maybe, yeah, it can be a Bluetooth beacon that would command the device. But then your device has got to be set up to pair automatically, right? And that's a security risk. Yes.
So when looking at what folks are doing over the internet, going back to this location question, what kinds of location-aware content are you seeing folks search for? Restaurants is an obvious one. Where's the nearest Chinese food to where I'm standing right now?
Yelp is very popular.
Was that?
Yelp is very popular.
Yep.
Yeah, those kinds of things. But I think also not only in finding places, but also in keeping track of your friends, right? Location-based features around tracking where your closest circle of friends are is a very compelling application, especially if you look at the popularity of IM coupled with things like our users use MySpace a lot. And while MySpace doesn't have any location-based information, it's sort of the same demographic. Yes?
Have you tried to do any accommodation of larger amount of content by use of zooming?
He was asking earlier about things that we hadn't done. That's one thing that keeps coming up over and over again and we would like to do, but we just haven't. But you're absolutely right. Zooming would be great, especially for web pages. Many times people have wanted to be able to zoom in and get more detail, like if you're looking at a map, to zoom in so you can actually read the street name. Yeah, absolutely.
Okay, thank you very
Okay, all right. Thank you.
For information on other online Stanford seminars and courses, please visit study.stanford.edu.
The preceding program is copyrighted by Stanford University. Please visit us at stanford.edu.